In today's lecture, I'm going to provide you an overview about the Internet of Things, the different type of applications, the components of the Internet, and the architecture. Okay, so yesterday we have already made a very interesting brainstorming session with the students. And I would like to start again by asking questions to you. So what do you know about Internet of Things? And do you already use Internet of Things in your daily activities or life? So yes, anyone? Yes?
In my house.
Yes.
Smart house.
Yeah, smart house. So what use case do you use in your house?
I can turn on the AC with my phone.
Yes, this is one of the applications. So for example, you can have control about different type of devices. You can also observe through your mobile phone what is the room temperature, and based on this you can take decisions whether you want to keep it turning on or off. So what is the advantage of using this application, for example? What possible advantages? Yes?
It makes my life easier.
That's one of the advantages, yes. So IoT is basically to make the life easier. And another advantage, an economical advantage. It can save you energy because you can make a rule to turn off the AC, for example, when you reach a certain temperature. For example, if you want to have a temperature around 25, 24, so if it goes very low, you can have a logic or a rule that will stop the air conditioner temporarily or probably change the temperature in order to control the room temperature at your desired temperature. Okay, so what is the Internet of Things? So basically it's composed of two words. Internet, I think most of you already know about the Internet. Okay, so it's the network where everyone can communicate with each other. And usually the Internet was used for the PCs, for people to communicate using computers through the network. For example, exchanging emails or exchanging documents or anything else. But the concept since 2010 has evolved to also integrate what we call the things, which are basically small devices that are equipped with sensors or actuators, so that we can monitor them through the Internet. Okay, so what is a thing? So a thing basically or the IoT is a network of physical objects. Like for example, we have smartwatches. You may have a smartwatch. So what does this monitor, the smartwatch? The heart rate, yes. It can monitor your activity, basically, whether you are moving or you are sleeping. Now there are some applications that can tell you how many hours you have slept and whether you're sleeping were in deep or light. So it's basically, there is a sensor here called an IMU sensor or accelerometer sensor. Sensor هذا حساس التسارع. التسارع هذا, it can measure the acceleration in different directions, X, Y, Z. You know that the motion in space, it has 3 dimensions, X and Y and Z. Okay, so it can measure the acceleration, your acceleration, and based on this, we can use some, for example, machine learning technique or AI technique to transform this raw data based on the pattern into a classification of activity. So we can know whether you are, for example, sleeping, whether you are running, whether you are moving slowly or walking, and different type of activities. And one of the applications of this, for example, is to detect elderly people condition. For example, you know, elderly people at some point in time, they are not able to control their balance. So they may fall even without desiring this. So using this kind of sensing technology, we are able to detect fall detection. Okay, and based on this, we can send alarm to their children or to their family to notify them about a possible alert. Okay, so basically there are different type of sensors, and we can have actuators as well. So what is the difference between a sensor and an actuator? What's an actuator?
I think you have to do the act yourself.
Yeah, so it's a device that will take an action. You can say that an actuator is a device that will take an action. For example, we can have a water pump connected to the Internet as an actuator. So what does it do, the water pump? So you can activate on or off, for example, to make irrigation based on some sensing information that you can have. And this is called smart agriculture or smart farming, الزراعة الذكية. Okay, so we can have soil sensor that we can plug into the soil, and it can measure the amount of humidity. Okay, مستوى الرطوبة في الأرض. And in this way, for example, if the humidity level goes below a certain threshold, we can send a control command to the actuator to start pumping water for the irrigation. Okay, and this is very important application because it helps saving the water resources الآن من أكبر الإشكاليات الموجودة okay one of the most biggest issues is the climate change that you have heard about it, right? And the climate change, it means that our natural resources are going to expire if we don't exploit them efficiently. It's really important. So IoT is one of the technologies that help promoting sustainability and istidama. And this is one of the biggest trends nowadays. You have heard a lot of conferences and talks about climate change, global warming, sustainability, okay? And the Internet of Things, basically in smart agriculture, it helps promoting this sustainability. So as a first definition, the IoT is like kind of connected devices. And these devices now, they can be categorized as sensors or actuators. Any question? So also the Internet of Things, it's about data communication. So these sensors are connecting through a network. What is the objective? Yeah, to collect data, and probably we can save the data into some repositories for later data analytics. So there is a part that is about data exchange. So these devices will communicate and interact with each other with systems enabling data collection and analysis. And the IoT, of course, because it's an Internet of Things, it's based on the internet connectivity to control and remotely monitor these devices. So what is the history of the IoT? So the term Internet of Things was coined quite early. It's in the 1980s. Okay, but that was a very early concept. You know, at the 1980s, this was the start of the internet or network computer communication and networking. And then in the 90s, there is the development of the World Wide Web, WWW, okay, which allow you to connect through the internet through a browser. And later in the years of 2000, you know, there was the emergence of what we call wireless sensor networks. Okay, I was one of the first to start working on wireless sensor network when I was as a postdoc back in 2004. And this basically, it constitutes the foundation of the Internet of Things. At that time, we didn't talk about Internet of Things. We talk about wireless sensor devices. Now, for example, my mobile phone or your mobile phone is a wireless sensor node. Why it's called the wireless sensor node? It has what? What are the sensors that are in the mobile phone? Microphone is a sensor, yes. Huh? No, an interface is not a sensor. So sensor هو الحساس يقوم بتحسس شيء معين. These are not sensing devices. These are communication interfaces. Yeah, that's a good point. They have receivers, so they can sense the maybe interference or radio signals. But it has many other sensors. شو ما الحساسات الموجودة؟ كاميرا. حتى هو حساس نفس الشيء. شيء آخر. Motion. The motion is called accelerometer. Okay, accelerometer or IMU sensor. This is what we call a motion sensor. وفي عندنا أيضا gyroscope اللي يعطينا orientation or the compass. This device, it has many sensors, and it can be considered as part of the Internet of Things. It has GPS also. It knows your location, and this is what Google does. It uses your GPS location to know where you are, and it will sense the information. كنت كلمت على مثال how Google now, when you make Google Maps, Google gives you, for example, the traffic condition on the road. How does it know that? You are participating into that. Okay, it's because your device is giving to Google your GPS location and is giving also your speed. So while you are moving in the car, Google can take your speed and the speed of all other drivers, and based on this, it can know, for example, this part has a congestion because the average speed in this segment is very low. It's probably below 20 kilometers per second or 30 kilometers per second and so on. Okay, so you can see sensing now, it's part of our daily activities. Okay, your colleague already talked about smart homes to control the light or to control air conditioning, or you can control different type of things. So in 2010, this is the real start of the Internet of Things as a concept. And I remember at the time, some researchers start writing, okay, it will become a day where we can control the refrigerator from the internet, we can know what is the temperature about, we can control different type of devices. So that was an early concept, and it took only a couple of years, maybe 5 years to 6 years, so that we see this concept now commercialized. And the emergence of cloud computing, the big data analytics, machine learning, it accelerated the adoption of the Internet of Things. And now we are in the present days, in 2024. Now the biggest buzzword is about artificial intelligence. And artificial intelligence, it has also promoted the adoption of Internet of Things, because AI, especially with ChatGPT and the current large language model, it has the ability even to understand any kind of data, even text or unstructured data. So we can take the information from the IoT devices, and then we can make a complete analytics about this information. So let's look at some statistics about from business perspective. شوفوا الأرقام الآن موجودة بالنسبة لقطاع الأعمال في الانترنت اوف ثينجز ماركت، السوق الموجود. Okay, so the IoT global market is expected to grow from 611 to 618 billion dollars in 2023. This is the, and will be projected to be almost $3 trillion by 2023. So you can observe the amount of money and investment that will be put into the IoT market. And this is because it's really pretty much important. And this will projected CAGR ranges from 25.8 to 30%. And let's look at the numbers in Saudi Arabia here. Yeah, the IoT in Saudi Arabia. Look at the global market. The current market now, it's about $11 billion in Saudi Arabia, the IoT market. And there are several big companies here, like Machine Stock, which was also acquired by IoT Square, okay, which is part of the PIF. This is the biggest company currently now in IoT in the Saudi market. And there are different type of sectors. So the automotive sector is taking about $3 billion, the industry IoT $2 billion, and the consumer IoT is $1 billion in 2024. Okay, let's talk about IoT application. Any question now? هل في سؤال؟ Okay. So how can we use IoT in smart farming? Yeah, tell me how. So imagine that you have a farm right now. Anyone interested in farming here? I'm basically interested into that. Okay, so imagine that you have a farm. What you'll be concerned about? You'll be concerned about your plants. Okay, and plants, what do plants require? They require humidity, yes. Must have water. Anything else? Sunlight, yes. What else? Soil. Soil what? Soil quality. في minerals. في potassium, في phosphor, في nitrogen, and they have to be provided in a balanced manner. If you provide a lot, okay, it's going to harm. If you don't provide, the plant wouldn't have nutrition. It's like we take vitamins, okay, through the food. And even the soil quality itself, okay, the conductivity of the water and so on. So how can we manage this? Okay, now the classical way is what you will do. Classical agriculture, what they will do. How do they irrigate? I don't know, they will just irrigate. Maybe they will put a lot of water if they have abundant water, or occasionally they will put water. So there is no way on how we can measure whether we need to irrigate or we don't need to irrigate. So that's an issue. And especially now the water resources becomes very scarce. Okay, الأمطار شحت عن قبل. Okay, it's really important that we irrigate only when there is a need to irrigate. It's not because just I have water I need to irrigate every time. And over irrigation, it may also affect the plant health. Okay, يمكن يصير فيها تعفن بالجذور. So it's really important now. How can we, for example, monitor the irrigation in an automated manner? شاركونا في الخلف. واضح كلامي ولا أول شيء؟ نقول بالك نتكلم في أشياء مش مفهومة. Implementing a sensor in the soil, yes. What does it do?
To measure like the humidity and other minerals inside this.
Okay, and how can we make this automated through the IoT? I don't want any human intervention.
Well, a sensor gives a signal. That's the
signal to whom?
To let's say another sensor or system that can irrigate the plants.
Okay.
If the humidity is low, then it will send a signal to irrigate the plants.
To, for example, a water pump or something else. Yeah.
When
So
it reaches the correct level, it sends a signal.
no, yeah. So this is a good scenario where we can content. You can use also soil sensor to give alert. For example, now it's time to do more minerals for the soil. Okay. It can also be, for example, to monitor the soil moisture. Okay, the temperature. Also, the soil has to have some temperature for the crop health. Okay, we can use also some kind of radiation sensors to give us whether the plant has diseases or doesn't have diseases. Fertilization, okay, and to reduce the resource consumption. Now, in healthcare, for example, here, I already gave an example with the smartwatch. And in smart cities, so we can use to manage the traffic flow. Now, this is what exactly Google is doing with Google Maps. And this concept is called participatory sensing. معناها الحساسات التشاركية. بعض الأحيان نسميهم crowd sensing. لأنه we use the crowd and we use people in their environment to get their information. طبعا هذا فيه بعض الإشكاليات مثل privacy. Okay. And you know, there is no privacy basically. When you are connected to the internet, you lose everything related to your privacy. You are fully configured, profiled. All your information is already shared with many third parties. So, but of course, yesterday we had a good debated discussion about whether this is good or bad. I can remind about this. There are benefits and there are drawbacks. The benefits is that you are part of the ecosystem, so you're going to benefit from other contributions to the crowd sensing. So, for example, you will get information about whether the traffic road is congested in this area, so can take another one. So you reduce your time, you'll save your money, you'll consume less fuel. So you have advantages. But at the same time, you don't have any clue about how your information is going to be used. Now, if it is used only in this use case, that's fine. But if it's going to be manipulated in some of the ways, maybe they use your information to sell it to others. That's what most likely is going to happen. So they can take money without your consent. Okay, and so when the service is free, we are the products. That's the rule of thumb. Okay, so all the services they are not actually free. You know, you're paying in some of the ways. You're paying by providing your data, and this is what you agree on the agreement when you sign up to Google or sign up to Amazon or you sign up to any kind of distancing information. Okay, so it helps also in smart cities to optimize energy consumption. I also gave the example about monitoring the light into tunnels. Okay, in long tunnels, for example, there are always lights that are on, and this consumes a lot of energy. So in some countries, they can use sensing technologies. For example, if it is daylight, they can reduce the amount of light. Okay, there are some kind of special type of light, dimming light. Okay, and they have different level of intensities. So we can reduce the intensity, for example, during daylight, and we can increase the intensity during. So we can have, for example, a light sensor. If it is daytime, we can reduce the intensity. So in this case, we save a lot of energy. So you can imagine how many lights are spread around the city, and you know, if you save several hours a day about light intensity, you're going to save like billions of dollars over the years. And another way also is to turn off, on and off the light. And this is done, for example, in some في بعض الممرات يعني للمشاة أنه الأضواء ممكن can be alternating between on and off whether, depending on whether there is a motion or there is no motion into the area. It can be used in waste management. يستعملوها أين في waste management. So how can we use it in waste management? في الحاويات أكرمكم الله البلدية. Okay. So they can optimize actually because they have to have a lot of truck that will take this waste and dump it. And in some places, maybe they don't have a lot of waste. So imagine that every time you have a truck that will come through an area that they don't have sufficient waste. There is still, so they can put a sensor into the waste container to measure whether the containers are full or not. So if they are not full, they can actually take another route. No need to come today to this quarter or to this location. And this can save fuel. They can save energy consumption. Okay, by monitoring the waste management. This is one of the most important use cases. I have seen this in several exhibitions like LEAP, or the Internet of Things Expo that was held before. I think there are several companies working on the waste management, and it's already, I think, deployed here in Riyadh. And also enhance the public safety. هذا غالبا يكون عن طريق الكاميرات المراقبة. Okay. So smart homes, we already talked about this use case. Industry 4.0, so this is the use of sensing devices in production processes to optimize the efficiency, reducing downtime, and enabling predictive maintenance. طبعا الindustry they work 24 hours 7. Okay, so they don't have room for shutdowns, they don't have room, they need to optimize all their processes, especially if they have supply chain or if they have like different type of manufacturing devices. So here usually we use IoT sensors in order to have real-time monitoring of everything that is happening into the production pipeline. And another concept is vehicular network, which are known as connected vehicles. They share data about traffic conditions, road safety, congestions, and you can have a heat map about the density of congestions over a city, or also the distribution of CO2 over a city by connecting some sensors and collecting data over the time. Okay, smart grid, smart supply chain management, retail IoT, all of these are other type of IoT applications. So look, this is a real example of a mobile app that is providing the energy produced by solar panel in a mobile phone. في solar panel الطاقة الشمسية تقوم بتجميع الطاقة. Okay, it will produce electricity and give it to, for example, شركة الكهرباء. Okay, electricity company. And this will help what? It will help reduce your invoice at the end of each month. So yeah, usually people are concerned about how much I'm producing every month. And we have also العدادات بتاع الكهرباء. They can tell us how much you have consumed electricity every month, and then they will make the balance. Okay, so now you can see the energy produced during the daytime. And this will give you an indication about what? About the efficiency of the solar cells. Okay, فنشوفوا الآن طبعا هذا خلال فصل الشتاء، يعني التجميع يبدأ من الساعة 8 إلى الساعة 4 لأنه الوقت قصير. طبعا in the summer you will have starting from 5 a.m. until maybe 7 or 8 p.m. depending on the region. So this kind of application is very important. So at least you can monitor the energy produced by your solar panel, and if you can have also, for example, displaying by month, by year, and if you see that there is a reduction in the produced electricity, so in this case you may think, oh, probably I need to make some maintenance for my solar panel. Okay, so you can observe now. I'm giving you several applications types to get some intuition about the importance of using IoT devices to improve the quality of life and also for better efficiency of the resource management. Okay, so here you can observe that the amount of power produced during the day was 30 kilowatt, and this is the distribution of power during the day. Okay, this is an example of an IoT application that we have developed into one project with my students maybe 4 years ago. And this application was about monitoring the red palm beetle, سوست النخيل. سوست النخيل, this is one of the most devastating health disease for palms. Okay, what it does, تأكل في النخلة من الداخل. Okay, and the problem, if you don't, it's difficult to make an early detection. And because the palm will look like it has an excellent situation, and there is already beetle that is eating the palm from the inside. And it's after a couple of months, maybe 3 months, 4 months, 6 months, that you suddenly find that this palm is going just to drop off. And you can never recover it. And imagine that this insect, if it is spread around many farms, is going to kill like the whole natural resources related to palms. And this is one of the most critical issues here in Saudi Arabia. I have worked with people from King Saud University working on the red palm beetle detection, and they are struggling. But look at the beetle here. This is now eating. I brought 4 of them, small, and after 2 months I had maybe 10, and they were flying around the lab. It was kind of an amazing experience. And from there we are able to detect. We can use vibration sensor or sound sensors, and these sensors will allow to monitor the activity of the red palm beetle while eating the palm from the inside. So how can you use the vibration sensor? How can we detect the red palm beetle from a vibration sensor? شو يسوي الفايبريشن sensor؟
Because the vibrations of the palm.
يعطيك signal when there is a vibration. Okay, and we can also use acoustic sensor. Acoustic sensor هو عن طريق الصوت. So both of them are viable solutions. طبعا what are the challenges here if we use acoustic sensor or a vibration sensor? imagine that you hear a noise or a vibration. Yeah, you don't know whether this is related to a red palm beetle or someone coming through the, coming close to the palm, or another insect, not the red palm beetle. So how can we manage to detect the red palm beetle? What do we need to know, to do?
Maybe concentrate this.
Yeah, because these sensors, they will give us like raw signals. بالنسبة للعين البشرية كأنه noise. لكن this noise has a pattern. How can we identify the pattern? Yeah, learning the pattern. This is now the part of machine learning. So machine learning or signal processing, they are approaches that can transform a raw signal coming from a sensor into an information. And whether this information can be classified as a red palm beetle or something else. Okay, so it's important to complement the data collected from IoT with some artificial intelligence technique or machine learning technique in order to process that data and get insights or insightful information out of the data. واضح? Okay, and this is what, and you know, we put also some moisture sensor, temperature sensor, and you can have a dashboard. And this is the status of the vibration sensor that will tell us whether there is an infection of the palm or no infection. طبعا this is from technical perspective, it's feasible, لكن from practical perspective there are many challenges, and the biggest challenge is the cost of the sensor. Because if you have a farm of thousands of palms, you know, we need to have sensors at very low cost. But usually now the sensors in the market يمكن أقل سنسر في حدود 1000 ريال ولا يعني sometimes it's even $1,000, $500. So it's not really practical to put every sensor, you know, it's not cost effective to put every sensor in the palm leaves, yes. Yes, that's another challenge because you must have all these sensor devices connected to the internet, okay, connected to the internet so you can monitor them. So you need to have energy close to the farm, you need to have internet connection, you need to have network coverage, okay, you need to have also sufficient range to send the information because usually Wi-Fi, how many meters is going to send you, you know, 10 meters, 20 meters maximum, maybe now 300 meters, but you can have farms kilometers away. And this is why we need different type of communication approaches. الواي-فاي مثلا الآن it's not sufficient to be used in these type of devices. لأن أول حاجة it consumes energy and most of these sensors are battery powered. كلهم يشتغلوا على البطاريات. تخلي بطارية تسمع الواي فاي 5 دقائق ولا خلصت البطارية. يعني this is not useful. There are many challenges when it comes to making this technology as a business and something a viable solution. من الcost, economical challenges. في communication challenges, how we can connect all these devices, maybe thousands of devices, 10,000 of devices, all together through maybe a gateway and then connect them to the internet. That's another big challenge. And this is why these solutions, you know, they exist, but you know, they say you can take the sensor in what you think that the most contaminated place and you put it in different palms just to make, for example, if this palm is infected, I'm going to look around for the other palms. like a cluster, بعد يبدأ يتوزع الكلاستر هذا. في techniques اللي أرادوا يستعملوا فيها drones. لكن with drones it's not possible to make an early detection. Maybe with the drones you can use some hyperspectral cameras that will give you the information, but after the advances of the red palm beetle into the palm. معناها وقت اللي توصل النخلة إلى مستويات غير قابلة للرجوع. ممكن نستعمل drones على أساس إنه بعض الأحيان they can make a survey about the whole area to see the distribution of infection. لكن لازم تكون واضحة للعين المجردة. Okay. To be able to use drones. So the IoT system, as already mentioned, it's composed of sensors. We already talked about this as actuators. We gave already examples, and also embedded systems. And these embedded systems, they are small computers, مثل Arduino or Raspberry Pi or another type of boards that usually has low power consumption. أهم حاجة في IoT, your devices must have low power consumption. ممكن يشتغلوا على بطارية 3 volts, 5 volts, 6 volts, 9 volts. Okay, so you need to make sure that we don't overutilize the energy resources. Okay, so how energy will be dissipated in a sensor node? What are the source of energy dissipation? كيف يمكن نستهلك الطاقة؟ What does it mean active?
When the sensor triggers the energy.
Okay, so when the sensor is going to make a sensing activity, sensing task, يتحسس. ممكن نخلي sensor like in sleep mode. يسوي ولا شيء. No sensing, no other task. So this is going to save energy. But I need the sensor to sense information. Okay, so what does affect the energy dissipation? Let's take we take the extreme case, no sensing, sleep mode. The other case, I will put the sensor always active, always sensing. Is this efficient? Is this efficient?
Yes, because of consume energy.
So it's efficient in terms of quality of service. It will provide you always values, but it will consume a lot of energy. So what's the balance that we need to do? What is the balance? Hmm?
Specify the cases.
Specify the cases. What does this mean? Specify the cases.
And when specific case happens, then sense it.
Yeah, this is called event triggering. I mean, okay, how do we know that there is an event? I need to sense to know whether there is an event. Okay, so we can turn it on and off. I can make it work 1 second, off another second, because this event usually they will come in a continuous manner. So if I make on and off at different intervals, this is what we call the duty cycle. Okay, for example, if I work 1 second and I go into sleep mode 1 second, this is 50% duty cycle.
Still, it's insufficient. So it's not efficient.
Yeah, but sometimes we can sleep for 1 minute and wake up for 1 second. So I can make the duty cycle at 1%. So the duty cycle is defined about how often the event may happen. Okay, sometimes you may need it to, if there is an event detected, you may need it to activate it for longer time. But when you say, for example, I want to detect, for example, sensing temperature, the temperature is not going to change every second. Okay, if you want to make a sensor to sense climate temperature, I can activate it once an hour, because usually the difference of temperature in 1 hour is going to be small.
What about automatic doors? Automatic doors are always.
Yeah, now these automatic doors usually they are not battery powered, they are mains powered, so you can put them active the whole duty cycle. But if you want to save energy, so usually this is what we call the frequency of activation. Usually they can work at 10 hertz or 100 hertz. It means they will go on and off 100 times a second. Okay, well they provide you 100 values per second or 10 values per second. So you can define also the frequency of operation, and it will affect the energy consumption as well.
Or I can use it depending on the event. For example, if I have a plant, I want to measure about the energy of the sunlight, I could turn it off at night and turn it on.
Yes, yes, yes. If you make, for example, a moisture sensor, maybe you need to monitor this once a day to save energy. So it depends on the use case. You will define what we call the duty cycle for the system. So the sensing is one of the energy dissipation issues. But there is even a more dramatic issue. Which one? Communication. Communication, it's devastating. Okay, now if you use Wi-Fi, you're going to consume your power quite. There is low power Wi-Fi right now, but still, you know, it's good for several IoT devices, especially if they are mains powered. But if they are battery powered, there are other viable solutions. Like there is a solution that you already know. Bluetooth. Okay, Bluetooth, it's one of the communication protocols for IoT devices. And Bluetooth is more energy efficient than Wi-Fi, but still it consumes energy. And this is why the embedded system community, they have worked in the era of 2003 up 2009 into defining special protocols for sensing devices. Okay, and one of the protocols known now in the market is called ZigBee. I don't know if you have heard about this. The ZigBee protocol, if you buy sensing devices from Amazon, some of them, they have the ZigBee protocol. And usually they use these protocols for devices that are battery powered. But in this case, it cannot communicate with Wi-Fi or the internet. It must communicate, ZigBee will communicate with another ZigBee device. So usually we have a special device that we call gateway. And this gateway will communicate with all ZigBee devices. And this gateway will be connected to the internet through Ethernet cable. So I can get the information, make data collection, and then send it to the internet, to the cloud. Okay, so this is the way on how we can collect data. And the good thing about ZigBee is low power and long range. Yani, theoretically, they say it can go to several kilometers, 20 kilometers, 10 kilometers, 1 kilometer, depending on the power that is used. And I know that there is a satellite launched in Tunisia 2 years ago. It communicates with the Earth through ZigBee also. Now, they use it also in satellites. And you can imagine this is like thousands of kilometers away. Okay, and still ZigBee, it's one of the technology now used. But the problem of ZigBee, it's only supports very small amount of data, low bandwidth. ما يستطيعش يرسل بيانات ضخمة مثل images. And this is sufficient because in IoT devices, we usually send small number of bytes. So we don't need high bandwidth. Okay, and there is a problem of latency because usually these devices are low power mode, so they are prone to more latency in processing the bits that will be sent over the network. Is it clear? Okay. So the lesson learned, now we need to have low power devices. There are different types of networking protocol. Communication is the big bottleneck in terms of energy consumption, and this is why when we have battery powered devices, usually we will use the ZigBee protocol. This is at the network layer, and in the MAC layer it's called the IEEE 802.15.4 and some of its variants. مثل IEEE 802.11 اللي درستوها on Wi-Fi. درستوا networking?
Yes.
Okay, so you understand these terminologies, right? Okay. So there are different type of sensors. We already talked about them. This is just a summary. We have temperature sensors. They can provide you the temperature information. Motion sensors, so they can detect you when you move in proximity to them. Okay. Yes. Exactly. Yes. So they are sensitive to lights, to motion. Okay, and they are used for home security and home automation, industrial sensing. Humidity sensors, قيسوا الرطوبة. والpressure sensors. Okay. So major pressure in various applications like automotive systems, medical devices, and industrial machinery. In cars, yes. So the car is full of sensors. And the problem is one of the sensors fails, I'm going to have a lot of issues with that. Soil moisture sensor, we talked about this also, okay, to optimize irrigation and prevent over-watering. Temperature sensors that are used for بيوت مكيفة, greenhouses, and light sensors also. So this sensor is the accelerometer I talked to you about. It's able to provide the information about the acceleration, and it is used for activity tracking and gesture recognition and vehicle diagnosis. هذا موجودين في الجوالات الآن, and they are able to detect different type of human behavior. Gyroscope, so measure the angular velocity and rotation, used for motion detection and also for stabilization. This is used in navigation system. في الطائرات هذا من أهم الحساسات الموجودة في الطائرات. هو المسؤول على stability للطائرة. And I think one of the issues is the Boeing 4 شيء اسمه البوينغ اللي دائما فيها إشكاليات 747 أظن أو شيء. It's the issue of, I think they didn't make the application of gyroscope and it was crashing issue. So gyroscope is very important for system stability, especially the aircrafts. GPS are also type of sensors that provides your localization, geographical localization. And magnetometer sensors, they are use magnetic field to provide you the orientation. And this is used in compass. Okay, بوصلة تعطيك الاتجاه north, south, east and west. موجودين في السيارات أيضا. شوف بعض السيارات. نعم في القبلة نعم موجودين. ذلك الآن عن طريق الجوال you are able to see القبلة عن طريق الماgnetometer sensor. So some of the commercial application of IoT devices, and this is something that you can find on Amazon. You can plug them if you want into your home system. And these are pretty much amazing devices, like smart switches. So smart switches, you need just to connect electricity to them. So you can, for example, make a wired connection to one of these buttons. But another most amazing thing that you can do, you don't need to wire all these buttons. But if you have other devices, like for example, smart bulb like this, and this is already a connected device, and this one is a connected device, so you can make a program through a mobile app. If I click on this button, I want to turn on this light without making any wire connection. So it will go through the internet and send the control signal wirelessly through the internet. And this is cost saving. And من أكثر الأشياء that you need to spend a lot of money on them is the electricity wiring when you build a home, for home constructions. So you can save a lot of cables and just put your plugs wherever you want. You just need to have internet connectivity within your house, Wi-Fi coverage, and then you'll be able to connect this one. You can open a bulb, this one, you can open your garage if you want, okay, without having a physical connection between this button and any other device. Okay, so any connected device, it can be remotely controlled through one of these programmable buttons. So this is an energy smart energy meters. So this type of devices في مثل sensors here that you can plug them into the two wires اللي يمشوا في العداد. العداد دائما لما يجي من الكهرباء في two wires. لو تخلي فيهم sensor device هذا, it will measure the energy and also the voltage and the electricity. And from this you can estimate the energy produced and consumed into your home system. Okay, and you can have your energy consumption with all statistics through your mobile phone. You can set thresholds. For example, if I reach this level of consumption, give me an alert. Okay, this helps you to control your invoices. And you know that electricity prices are going very high, so many people could take benefit of this. You know, they are very cheap. You know, maybe 60 riyal, 70 riyal. You can buy one, plug it, and get your home connected to your mobile phone. And these are smart plugs. Also, if you want to control your, I don't know, your coffee machine, you want to get up in the morning and automatically just start your coffee machine to get your coffee ready as you get up. That's feasible also. You can just make a plug there and control it, yes.
How is it considered smart?
It's smart because it's connected to the internet. So this one,
Yes.
it has a button from here. You can connect this device to the internet, to your Wi-Fi network, and then you will have on your mobile an application that will allow you to control on and off this device. And then in this application, you can make different control rules. For example, at 7 p.m., I want to turn on this device. At 9 a.m., I want to turn it off. So you can make a program on a mobile device about the activity of your smart devices. Okay? So if you want, you can, you know, it's very cheap. You can try to buy one, and you know, there are an application, this smart life application, connect to them, and you can play with these devices to see how it works. Okay, this is a sensor for soil monitoring. Okay, provide acidity, okay, level, the fertilization level, the moisture level. Okay, it's usually, this is connected through Zigbee, okay, to a gateway, and from a gateway it's connected to the internet, and you can have, for example, you have 46% of humidity of the soil. So this could be, for example, an alert that probably you need to put more watering to that. And you know, because even some of the trees, they have different watering requirements, so you can manage based on this application. How this is for water quality monitoring. Okay, نسبة الملوحة ونسبة المعادن في المياه. إذا نسبة الملوحة مرتفعة جدا تؤثر على التربة، تؤثر على نمو النباتات. So from there you can actually measure the water, especially if you bring it مثلا من natural resources الآبار. Okay, إذا بستعمل you can mix, for example, salty water with مع المياه الطبيعية. Okay, in order to avoid compromising the soil quality. Smart irrigation systems and smart fertilizer systems as well. These are possible devices that you can use in smart agriculture. Okay, so the IoT, it has also contributed to or leveraged the emergence of other IoT technologies, including 5G, 5G or 4G before. It's a very important and crucial technology that allows the communication between devices anywhere and anytime. So it's IoT, it's about connecting devices anywhere and anytime, accessing them anytime. And 5G are high-speed mobile network that facilitates data transmission and seamless connectivity for the IoT devices. Artificial intelligence, leveraged with the IoT, is integrated with the Internet of Things for enhanced data analytics and also decision making. كيف نستعمل ال AI؟ أول شيء we can process raw data. كما قلت لكم الآن, if you have accelerometer data, or you have vibration sensor, or you have acoustic sensor, it will provide just signals. But you want to know whether this signal, for example, represent an infection in a palm tree or a motion. So you need to classify that signal, okay, which usually is a raw number of points. So AI is used in this respect, and based on this classification or inference that we do on the data, we can take decisions or make actions or activate actuators. Edge computing, it's also another emerging topic. So usually where we store the data when it is collected? In the cloud. صح ولا لا? Imagine that you have one cloud that collects. So cloud is something like central. It collects everything. Now, what will be the issue for the cloud? Scalability issue. And مثلا millions of devices that will be connected to only one single server. كل البيانات بتجي في server واحد. that's an issue. لأنه في الأخير السيرفر عنده capacity in terms of storage, in terms of processing. تخيل الناس الكل تشتغل على سيرفر واحد. The server could be done because of the load. Okay, if you expand the server more, you'll have to pay a lot of money. So what's the alternative? Is to use smaller server that we call them edge devices that will be more into the vicinity of the sensors. مثلا ناخذ مجموعة من السنسور، مثلا نقول كل البيانات بتاع الرياض تجي في سيرفر في الرياض. كل بيانات جدة يكون فيها سيرفر في جدة. We will do kind of clustering. Every server for a particular type of sensors is called an edge device. And sometimes you can call it a fog device depending on, so it's in hierarchy. Cloud is like the central repository. Fog, it's more decentralized. And edge will يكون غالبا close to the device. Okay, this is what we call edge computing. مثلا I have a farm. مثلا تخيلوا وزارة الزراعة طب يستعملوا حساسات في الزراعة مثلا. They cannot collect all the information, raw data from every farm. So maybe every farm will have a server, or a couple of farms will have a server that will collect their data, another one collect their data, and then we send aggregated information into the main cloud. So it's like a hierarchy of servers to make the system more scalable. So we don't overload one server with a huge amount of information or data to be processed or stored. Yes?
Doesn't it cost more to have multiple servers?
Yes and no. You need to have the infrastructure, but if you want to have a single server that monitors everything, it's not going to be cheap. But also, you'll have a single point of failure. Imagine that you have an issue onto that server. Everything else is going to be stopped. Okay? So decentralization is one of the ways that we use for fault tolerance, not to rely on only one server. So we don't have a single point of failure. If you have one server, you have a single point of failure. If this server fails, everything fails. So you need to have alternatives on how you can manage yourself. And blockchain, this is used for ensuring the security. Of course, blockchain is known. It's used in Bitcoins and one of the first applications. But the problem, the integration with IoT is challenging because this is resource greedy. But there are a lot of works that have adapted blockchain to be used with the Internet of Things, which are resource constraints. Okay, so the top IoT use cases, it's used in predictive maintenance, energy optimization, enhanced decision making, and automation. This is kind of the lessons learned from all our discussion about the different use cases that we've talked about. Now there is a trend of integrating IoT with large language models. What is large language model? ChatGPT ما تعرفوش؟ النماذج اللغوية الضخمة. ChatGPT تعرفوا ChatGPT? You already use it. This is called the large language model. Language model, which is very large. And this is why it's able to do pretty much everything. It's quite impressive. Okay, and when you're going to have an AI course, you'll be amazed about this type of technology. I work in AI, but ChatGPT and large language models are the most amazing technology that we have so far, because they can do almost everything. Of course, everything from like text and image perspective for processing these images. So the integration of large language models, we can use their ability to better understand our data. Now, if you take anything to ChatGPT, summarize me this text, make me an analysis of this data. It has the ability of interpreting the result like a human brain. So the same thing, we can use large language models to be integrated with IoT to enhance the security. So when the data comes, we can use the large language model to detect whether there is a security threat on the system or not. We can use it to automate operations. Okay, we can use it, for example, for generating scripts that will analyze the data. Now, with the advantage of LLMs, it's possible to send the data and tell the LLMs create a script that will analyze this data, extract results, and then write me a report about that. This is one of the use cases that I did with Libellium company as a demo. We took their data and then send it to the LLM, and then we generate a report. Your data means you have a threat, you have a high CO2 pollution into this area, you have an issue into that area, and so on. Everything is done by a large language model like ChatGPT or Claude Anthropic also. It's another alternative. Now there is DeepSeek. It's very recent, like maybe 3 days ago. DeepSeek is the OpenAI alternative from China, and it's taking a lot of momentum. I recommend you to try it. It has an impressive performance like ChatGPT also, with a much lower cost for its API. Intelligent data analysis. Okay, so the LLM can process large IoT data natural interaction, like Alexa. So Alexa use AI to understand your voice and then bring you back the response. Okay, like Alexa or Google Echo devices. Also, it does the same thing. And adaptive intelligence for of course, IoT doesn't come without drawbacks or challenges. So one of the most important challenges is the IoT security and privacy challenges that we talk about. There is a huge threat about data breaches. Now, imagine that your house is connected. So everybody can maybe sniff this information and understand what you're doing about. And the most dangerous part is that it can control some of your devices. Okay? For example, if you have a camera, you know, surveillance cameras everywhere, you know. Do you have any guarantee that these people that are selling the camera, provide you the service, don't have access to your videos? It's a big issue. Okay, although they say it's encrypted and privacy, but you know, personally I don't believe that this is perfect. And the device compromise, if you have Alexa or you have, especially with the camera, it's kind of dangerous. Okay, now it's say Alexa is going only to be triggered when you say Alexa, but it's still listening. And now the problem, when you're talking close to Alexa on private thing, do you have any guarantee that this is not heard, transferred somewhere else, being analyzed? You know, and Facebook has a big issue 2 years or 3 years ago that they are spying on people. You know, this is one of the issues of using these devices. It's true that they are improving the quality of life, but there are also some concerns about their usages. Another issue is about sustainability. And we talked about that IoT is good for sustainability because it allows to control, for example, the irrigation, the resource management, making more efficient the resource utilization. But still, you know, look at the amount of devices that are disposable, okay, and that could be actually disposed in the nature, and they can have an adverse effect about the sustainability. So it's not 100% pro-sustainable environment, but there are also drawbacks about how we can recycle all this amount of servers that will be utilized for the IoT. You know, the amount of energy that is consumed, the amount of heat. You know that, for example, just give you about OpenAI. Just to run OpenAI, it consumes the equivalent of 200,000 or 2,500 swimming pool amount of water just to run one server. Okay, just look at the amount of water that is being used to cool down the heat dissipated from servers. In artificial intelligence, same thing in IoT, in blockchain. So there are adverse effects about the massive use of or the massive impact on the environment. Okay, 27 billion connected IoT devices expected by 2025, which create an unprecedented environmental changes. The IoT devices consumes 500 terawatt of electricity annually, equivalent to power usage of many small countries. Manufacturers implementing recycled material, repairable design, and energy efficient component achieving 40% power reduction. Okay, this is to compensate the impact on environment. And growing IoT adoption generates 50 million tons of e-waste annually. So all these are challenges that has to be also taken into consideration globally. Of course, IoT are heterogeneous devices. This is why it is done in coordination with the IoT standardization and interoperability efforts to make sure that these heterogeneous devices are able to communicate with each other. Okay, so for the IoT skills and job requirements, usually if you want to work in the IoT area, you need to have expertise in programming languages like Python, Java, and C++, and also embedded system development. And these many technologies that we are going to cover during this course. You must have also domain knowledge. I mean, you must have an understanding about the different type of applications that we use in IoT, like in healthcare, how do you use IoT, in agriculture, in smart homes, in smart cities, in industry. Because if you want to implement a solution, you must know what are the challenges, okay, that you need to address to implement this solution. And of course, data analytics and machine learning, because every sensor is going to generate raw data, and this raw data has to be manipulated, transformed into an information. And this is based on analyzing the data and also doing machine learning. And to finish, this is the future outlook for the IoT advances. So I remember, back in 2000 when I started working with wireless sensor network, people were talking about we will have millions of devices that are sensors that you can spread them everywhere and they can collect information. This is what we call the smart dust. But this concept, there are some prototypes, but still it's not commercial at high level. So we think about sensors to be very small devices, self-powered. Self-powered, for example, they can take from solar energy. But the problem, solar energy is heavy, and you want to have small devices. So this is the big challenge, to monitor a wide range of parameters, enabling new possibilities in environment monitoring and predictive maintenance. But still, the sensor devices, they are not as cheap as $1 cost, okay? At least for now, to be spread largely into open environments. And the integration of blockchain to secure the IoT networks is also one of the innovations that is going forward, because the challenges here is that IoT devices are resource constrained and blockchain is usually resource intensive. But there are several adaptations to use blockchain to secure IoT data. Edge computing also, it's an important technology to have scalable IoT ecosystems where an edge device is able to collect a subset of sensors, aggregate them, and then forward the information toward the cloud. And quantum computing is to leverage quantum computing for advanced data analytics optimization. And the objective of quantum computing is to have smaller devices with much higher capabilities. But still, it's a concept. Google has already released a quantum computer that was able to break several records. But still, it's not at the commercial level so far. There is still several years when we say these quantum computers in our daily activities. So this is the end of the lecture, and we can open the room for discussions or questions if you have any. Okay, thank you. Let me just finish the lecture by reminding very quickly about